Okay, we are live. If there is anybody in the chat section, please let me know. Am I audible? Anybody in the chat section? Okay, so everything is fine with my stream. Let's just wait for 1 minute so that more students will join and then we'll start our session. So, hello guys, welcome back to our YouTube channel Geeks for Geeks. And in today's session, we are going to discuss about machine learning. Right? We are going to revise machine learning through question. We are going to see that how to approach questions. I have taken some of the question from mock exam and by myself. So you will see that how to approach any kind of question. And if at any point of time you feel any question, just let me know in the chat section. Okay. So let's start with the first question. So this is a gate mock question which all of you have seen from IISc. It says that which among the following may help to reduce overfitting demonstrated by a model. So just tell me what would be the answer here, guys. So the question here is, I hope all of you know the concept behind overfitting and underfitting, right? So they are asking that which among the following may help to reduce overfitting demonstrated by a model: changing the loss function, reducing model complexity, increasing the training data, increase the number of optimization routine step. So which would be correct here? So tell me, guys. So guys, let me give you a quick overview about underfitting and overfitting, because if you will see in mock exam as well, there are so many questions based on underfitting and overfitting. So this concept would be very clear to you. Before to understand underfitting and overfitting, you have to understand what is bias and variance. Do anybody know what is bias and what is variance? What is bias and what is variance? Bias means that we are getting training error. We are getting lot of, if I am saying that high bias, then it means high training error. That means our model is not performing well on our training data set, right? That means I haven't modeled correctly, so that's why I am getting so much of training error, that we call as a bias, right? What is variance? Variance is testing error, or I can say that if my model performs different on different data sets, we are getting a variance there, we are getting a difference there, we are not sure that we are getting the right results or not, then we'll say that that is variance. Or I can say that this is also my testing error. That means I am getting so much of difference in testing data, right? I am getting different results for testing data set. So that is bias, that is variance. If I'm talking about underfitting, in underfitting I have low bias, and I can say that low variance. That means my model is not performing well on my data set. That is my underfitting. If I talk about overfitting, overfitting means high bias, sorry, oh, that would be high bias, that is high bias. And overfitting is low bias but high variance. That is my overfitting. Right now, the concept you have to understand is that we do not want underfitting, we do not want high bias, and we do not want overfitting, because we do not want high variance. We want just right situation, that is low bias, low variance, right? So we want a generalized model. So at to reach at that stage, we have to reduce the variance and we have to reduce the bias, right? So that is a, if you have seen the diagram for, we call this as bias variance trade-off as well. So this is my, so at a certain point we'll get where we do not have high variance and high bias, and that point is my generalized point, and we call that, at this point we have our model, right? So that is a overfitting and underfitting. So now they are saying that how to reduce overfitting. Overfitting is what I do not have to fit my data so well on my training data that it would not do good on my testing data, right? I want a generalized result. So if you remember, changing the loss function would help overfitting. Tell me, changing the loss function, right? Changing the loss function would help. Have you heard about regularization parameter? If you will see in linear regression, lasso and ridge would help me to change my loss function, and using that we can reduce overfitting. So that is true, changing the loss function would help me to reduce overfitting, right? Similarly, reducing model complexity, this would also help, because if you will see in linear regression, if you will take a polynomial of higher order, that means I am increasing the complexity, so that would be fitted so well. That means I have a very low bias here, but I have high variance. So, but if I'll decrease the polynomial degree, then I'll get a generalized model, right? And increase the training data. Obviously, increasing the training data reduces overfitting, right? If I'll increase my training data, then I have so much of data to train. My model would work well, and it would reduce overfitting. Increasing the number of optimization routine step. If I'll increase number of optimization routine step, but this would increase the overfitting, right? Because I am increasing number of optimization steps. That means my model is becoming complex or more complex, and I do not want to get it more complex, because more complex model would leads to overfitting, right? So that's why fourth is not true. So first, second, third, which option is true? Option C is true, right? So let me know if there is any problem in this question. So I hope this is clear. So here option C is correct. Sort of changing the loss function would help, because I can add the regularization parameter. And regularization parameter is what? If you heard about that, is basically lambda into summation wi. So what would it helps to do? It would try to reduce my wi's, so that if I have higher degree, if I have more complexity, reducing these wi's values, I'll take lambda values too large, that it would, because I have to minimize the cost function or loss function, it would help me to reduce the value of wi, and it would reduce as much such that wi approximately gets 0, right? So that my model would get less complex. Yes, or that's what I'm talking about, right? Adding any regularization parameter to the loss function help me to reduce overfitting, like ridge and lasso regression, right? Adding regularization parameter help me to reduce overfitting. Let me give you one example. Let's suppose I have a polynomial, fx is equals to w5 x to the power 5, w4 x to the power 4, w3 x to the power 3, w2 x square, and w1 x plus b, right? This is my model. Now I can see that because it has a 5-degree polynomial, so this would be very complex. I do not want it more complex. So if I talk about the loss function for this, what would be the loss function? F of x minus y. This would be my loss function. Let's take square 1 by 2, right? That is my loss function. Now if because of this loss function, I just, what would I do? Because I know that these w5, w4, w3, these three terms would make my model so much complex, and I do not want that. So what would I do? I'll add summation lambda w, let's say, if I'll add here lambda w5 plus lambda w4 plus lambda w3. So let's take, if I'll take lambda value so high, if I'll take lambda value so high, so what would I get? Right? Because I have to reduce the loss function, I have to minimize the loss function. If I'll take lambda value so high, then w3, w4, w5 gets reduced to 0, right? And then in this, it does not have much of the impact. We'll get w3, w4, w5 approximately 0. right? So that's how this changing the loss function would work. uh, Now you can see that in what it is saying, that changing the loss function would help me to reduce overfitting. So here it is helping me, so we do not have to uh, go for decision tree and other thing, because it is helping me here to reduce overfitting. Okay, let's solve this question. Here I have to calculate precision and recall. Just tell me what would be the answer. Just tell me, guys, what would be the answer here. Saurabh, in decision tree, we usually prune to get a to reduce overfitting. So the question says that suppose a computer program for recognizing dogs in photograph identify 8 dogs in a picture containing 12 dogs and some cats. Of the 8 dogs identified, 5 actually are dogs while the rest are cats. Compute the precision and recall for this computer program. So, guys, I hope all of you know what is true positive, true negative, false positive, and false negative, right? So, if I'll talk about, uh, let me tell you what is true positive. Let's suppose actual true, and actual false, predicted true, and predicted false. So, guys, let's see. If predicted is true and it is actually true, then I'll say that that is my true positive, right? That is my true positive. And because I have predicted true but it is actually false, so I have predicted falsely positive, but it is positive, right? It is false, but we have predicted positive. Then we have here is false negative, because it is actually true but we have predicted negative here, false negative. And we have predicted true negative here, true positive, sorry. It would be true positive instead of, right? So this is my true positive and true negative case. And what is precision? If I'll talk about precision, that would be true positive upon true positive plus false positive. That is my precision. If I'll talk about recall, recall is true positive upon true positive plus false negative, right? This is the formula for precision and recall. Now let's compute that in the question, that how do we going to get this. Just tell me, guys. So now in this question, if I'll see a computer program for recognizing dogs in photograph identify 8 dogs in a picture. So it identify 8 dogs containing 12 dogs and some cats. So it has 12 dogs and some cats. Of the 8 dogs identified, 5 are actually dogs while the rest are cats. So I can write down there this as actual dogs, actual cats, predicted dogs, and predicted cats. So I can see that there are 12 dogs. Actually, there are 12 dogs, right? Actually, there are 12 dogs. Out of the 8 dogs, 5, they have identified 5 are actually dogs, while the rest are cats. While the rest are cats, which they have identified incorrectly. And because of this, actual dogs are 5. And what would be the predicted cats? How many of they have predicted wrong? How many of they are predicted wrong? Just tell me. Because they are saying that there are 12 dogs and some cats. So it would be 7, because that remaining 7 they have predicted incorrect. Let me know. Right? Now I can, because I want true positive, false positive, and false negative for precision and recall. Just find out that. Okay, so let's find out this. So I got from here that true positive, true positive is equals to 5, false positive equals to 3, and false negative equals to 7. Now you can find out precision and recall. What is precision? Precision is 5 upon 5 plus 3, that is 8. 5 upon 5 plus 7, that is 12. So that is my precision and recall. I hope you guys get it, how to find out this precision and recall. So just remember this. And there is one more thing which we can find out accuracy. Accuracy is what? True positive plus true negative upon true positive plus true negative plus false positive plus false negative. Just remember this in case they ask for accuracy as well. Right? So how much we are accurate, we'll get it from here. Let's see another question. So this is another question, guys. Just tell me which of the option is true. It says that, this is again a question from mock. It says that a binary classification data set contain only 5% of positive instances. So we have only 5% of positive instances. Which on one of the following experimental design and performance measure is most suited for measuring the generalizability of a classifier trained on this data set? Tell me, guys. Soyesh is saying 3 or 4. Tell me, guys, which of the option is true? Whether it is 3 or 4. Tell me, guys. Okay. So, guys, you can see that only 5% of positive instances we have. So that means 95% are negative instances. Negative instances. And 5% are positive. So let's suppose I'll divide that data set into testing data and training data. So let's suppose these, if I'll take 95% of negative, 95% of my negative values in my training data, and in this 5% I'll take in testing data. Right? So now you can see that there would be a problem, because it would give me negative, it would get modeled, and it would give me result for every model for negative, and we have in testing positive. So we'll get 0% accuracy. And in case otherwise, if I'll take in case, if I have modeled, this data, if I have modeled this whole data as saying that my final result would be negative, right? So if I'll check the accuracy over this whole model, then I'm 95% accurate. And in modeling, 95% is a good accuracy, right? If I'll take overall result would be negative, right? For this, for every instance it would leads to negative, for every instance it would leads to negative, right? So if I'll check the accuracy, because for 95% of my data it is giving me right result, it is giving me negative result which is true, right? So that means accuracy is 95%, and 95% is a good accuracy. So that means here accuracy is not working, right? So accuracy is not working, so I can say that uh, in this accuracy is not working and accuracy is not working. A and C are not correct, right? A and C are here not correct. Now next let's talk about, so that means area, I'll tell you about ROC curve as well. What is fixed training set and stratified cross validation test? And I told you about training set and test set. If I'll take fixed training and test set, there might be a possibility that all the negatives or all the positives gets to the test set, all the positives gets to the negative set. So there would be imbalanced data, right? This is an imbalanced data. So in case of imbalanced data, this thing does not work. Fixed training sets and test set do not work. We have to use stratified cross validation. And what is stratified cross validation, guys? So all of you know K cross validation, K fold validation. So what we do, we divide the data set into K parts, and we'll take K times this data set, and in the first time we'll take first data set as my training set, first first part of the kth part, right? And in the second time I'll take second part, in the third time I'll take third part, fourth part, up to K part. So we'll get K times multiple data sets, right? That is stratified, that is K fold cross validation. But in stratified there would be a balance of data. What is balance of data? If I have 95% negative and 5% positive, then in testing data, let's suppose this is my testing data, we have let's say 90% and 10% positive and negative and positive, like that. So there would be somewhat balanced. It would not exactly matches to my data, but it would be balanced. It would not something like that I'll get 100% of negative and 0% of positive. It would not occur like that. So that is my stratified cross validation. That we means we'll get that balance which we have in the data set will also be in our test set and training set. I hope that is clear. So that is my stratified cross validation. So I have eliminate accuracy because of this imbalanced data set, and because of this imbalanced data set I want stratified cross validation. Guys, can you tell me what is ROC curve? Anybody? ROC curve? What is ROC curve, guys? So guys, I can find out here true positive rate and false positive rate using true positive and true negative, right? So using this true positive rate and false positive rate, I can plot this curve. False positive rate here and true positive rate here, right? If I'll plot this curve, I'll get a curve like that, right? And if this area gets large, that means this because a true positive rate, that means how many positive value we are predicting. False positive rate, how many false values we are predicting. So that means this area, if increases this area, that means we are predicting right. So that's why area under ROC curves would work here uh, for imbalanced data set, because it works on precision and recall, right? Let's move forward. Just let me know, guys, if there is any confusion in this question. Otherwise, let's solve this. Increasing the regularizing coefficient value for a ridge regressor will. What would happen? What would happen if I'll increase the regularizing coefficient for a ridge regressor? Okay, Suyesh is asking what is intuition behind ROC curve. Okay, let me tell you in detail what is. If I'll talk about false positive rate, what is false positive rate in this? False positive rate is false positive upon false positive plus true negative, right? That is my false positive rate, and this false positive rate is fraction of negative examples classified, right? So that means negatively classified, that means wrongly classified. This is what false positive rate is, negatively classified. And if I'll talk about true positive rate, true positive rate would be true positive upon false negative, right? And that is my true positive rate. It false positive rate gets me fraction of negative example, right? This is what fraction of negatively classified. It would give me fraction of positively classified, right? This would give me fraction of positively classified. Now if I'll plot this data, if you will see, if I'll write down here FPR and if I'll write down here TPR, right? True positive rate. So can you tell me, if my point is here, what does it mean? If any point lies here, what does it mean, guys? Can anybody tell me that what does it mean? That means if it lies on this direction, that means it is a negative prediction, right? That means FPR is that, in this case TPR is 0, right? True positive rate is 0. That means true positive is 0 for that particular model. If I'll take any another model and it lies here, right, that means FP is 0, because TP is getting, I am here 1 and it is 0. So you can see that the model, if I'll take any model, right, this model, so you can see, right, so you can see that the model which is right, that means would be some model here, some model here, some model here, but this would give me the maximum prediction because it lies very closer to TPR, right? So the higher the area between the, sorry, just a minute, not like that model. So we'll get one model which have one ROC curve like this, we have one model which have ROC curve like this, which have one model which have ROC curve like this. So the ROC curve which have the highest area below that would work as my best model. So ROC curve basically helps me to get which model gives me best results. Right, recall and TPR are same. Right, you can remember like that, that recall and TPR are same. So that is an intuition, right? We'll for every model we'll uh, draw one ROC curve, and this ROC curve which have the highest area below that would give me the best results. Right, so you can see that na, true positive rate is high for that particular model and false positive rate is less. So what I want true positive rate more as compared to false positive rate. I'll not take that model. Let's suppose this is another model. This would not work because it is giving me 50-50%. There may be a chances that I'll get the right result, there may be a chances that I'll give the wrong result. So I do not want that. So let's see this question, that what would happen if I'll increase the regularization coefficient value for a ridge regressor. So guys, I told you that increasing the regularization coefficient lambda, right? What is regularizing coefficient? Regularization coefficient is lambda. If I'll increase the value of lambda, that would help me to reduce the value of wi, and if wi's value gets reduced, that would help me to work on overfitting, right? That would help me to work on overfitting. And what is overfitting? Overfitting is low bias, sorry, high bias, low variance. high bias, low variance. So it work with this problem, right? This is a problem. So increasing the regularizing coefficient gives me the solution to this problem, which is overfitting, and problem is high bias and low variance. So it would help me to reduce bias and increase variance, right? That's what I want. Okay, just let me know if this is correct. Kopu, I told you that model bias means that we are getting high bias means that we are getting lot of error. Sorry, okay, sorry. This is low bias, high variance. Over. Sorry, guys. This is low bias, high variance, and bias means that we are getting lot of testing error. So in this case, in overfitting case, we are not getting testing error, but we are getting training error so high. Right, Pratham. Low bias, high variance. Right, so it helps me to solve this problem. That means my bias gets increased and my I'll decrease the variance. So that means decrease model variance and increase or maintain model bias. So you can see that they are maintaining model bias. So that means first and fourth option B is true. Right, first and fourth would be true here. Just let me know, guys. I'm again telling you that bias means that we are getting testing error, and in variance, bias means that we are getting training error, and variance means I am getting testing error. That means my model is performing different on different data sets on testing data. Okay, so let's move forward if this is clear. Let's see next question. So this is another question. Again, this is a question from mock test. It says that given a K-class dataset containing n points where sample points are described using d discrete features with each feature capable of taking v values, how many parameters need to estimate for naive-based classifier? Ma'am, variance, please explain. Okay, let me tell variance once again. Right, guys, bias is what I told you. I told you bias is what testing error, training error. Training error. Bias is training error and variance is testing error. That means my model is not performing well on my test data set. Let me take one example. Let's suppose we have this data set. Right, this is my data set. Let's say I'm taking this yellow, and if I'll model this, what does it mean? If I'll try to use linear regression here, what would happen here? So you can see this line would not fitted well. So that means in yellow case, what happening here? I have low bias and low variance, and we call this case as underfitting. Underfitting. Low bias, low variance. Low bias means that our model is not performing on testing data, and it is not performing on training data as well. Now next thing is, let's say uh, if I'll take this kind of a data set. So that means in this I have, let me use more. Right, this is my data set. So what would happen here? In this case, in green one case, my model is just right. I'll tell you why it is just right. Because there may be a chances that I'll get this kind of a model. So you can see that the model is exactly fit to my data set. This is exactly fit, right? And exactly fit means that means I have a low bias. Sorry guys, it is high bias. This is high bias. I just usually get write down it wrong. So in this case I have low bias, because you can see that bias is very low, and we have high variance because model is performing well on my training data. It would not perform well uh, on my testing data, so that's why I have high variance. So this green model is just right. I have to make a balance between bias and variance to get the just right model. I cannot increase the bias so much to get you can see that I cannot increase the bias so much so that I'll get a low variance. It would not be possible. And I cannot reduce the bias so much because it would leads to high variance. Right? That is the reason behind low bias and low variance. Let's solve this. Given a K-class data set where sample points are described using discrete features, each feature capable of taking V values, how many parameters need to be estimated for naive-Bayes classifier? Okay, one thing. First of all, let's say we have C1, we have classes C1, C2, CK. We have CK classes. So first of all, I have to find out probability of C1, probability of C2, probability of C3, probability of CK. I have to find out probability of each class, right? So that means K parameters I have to find out here. Now, next thing is K class data set containing n points. So that means I have n points, n input points, n training points I have given. Okay, where samples described using d discrete features. So I have d discrete features here. Let's say uh, d discrete features, feature 1, feature 2, and feature d, right? And each of the feature is capable of taking v values. So that means f1 feature can take v values, f2 feature can take v values, fd feature can take v values, right? Each feature can take v values. So what I have to do, okay, Kopo is asking to explain naive Bayes classifier. So basically guys, if you remember Bayes theorem, what Bayes theorem says, that Bayes theorem says that probability a given b I can write down as probability b given a into probability of a, right? Or you can use that as well, that probability, this is my conditional probability definition, probability a intersection b upon probability of b, right? So using that I got that probability a given b, probability b given a into probability of a. So what I want to do, I have some of the features given. Let's suppose I have one value of feature 1, one value of feature 2, and up to dth feature I have one of values given. I want to know for this particular instant in which class it gets classified. For this it has C1 class, for this it has C2 class. Let's take one example. I'll tell you. Let's say I have hours students study, our students play, and our students sleep, right? And get the class here that it he or she gets pass or fail. So if it study 6 hours, play 4 hours, sleep 8 hours, then it gets passed. If it study 2 hours and let's say it play 5 hours and it sleeps 7 hours, then the student gets failed. So I have this result. So let's suppose I have one new instance, 4, 5, and 8. I want to know that the students get pass or fail. That means if the student study 4 hours, student play 5 hours, student sleep 8 hours, then he or she would get fail or pass. I want to know that. So on this type of problem, naive Bayes classifier work, right? So how do I find out that? I One thing is that if I'll find out, let's consider this instance x. So if I'll find out probability c1 given x, probability c1 given x, then I can know. Similarly, I can find out probability c2 given x, and c1 is what, that student passed, c2 is what, student failed. If probability of passing is more, then we'll assign this, that student gets passed. And if the probability is c2 is more, then I'll say that probability of students getting fail, right? And how do I find out this probability? Because it's not possible for us to directly find out this possibility, so I'll use Bayes theorem. So it would say that probability x given c1 into probability of c1, probability x given c2 into probability of c2, right? Now x given c1 would be I can divide this feature because these three features are independent. X1 given C1, X2 given C1, X3 given C1. Similarly for that one as well. So you can write down that, and using this data set, you can solve the question. Right? It would be more lengthy if I'll try to solve this complete naive Bayes theorem. So just try it once. Now I have given you the intuition behind that. Okay. Now let's get back to our question. Okay, let's get back to our question. So I told you that with each of the feature probability C1 given X, I have to find out these probabilities. So I have F1, F2, Fd feature. So that means for that one, for let's say probability C given F1, 1, and probability C1 given C2, C1 given F1, 2. I have to find out all these probabilities. Probability C1 given F1V, and similarly for this one, similarly for this one. So that for this one I have to find out V probabilities, for this one I have to find out V probabilities, and for this one for V probabilities. In total this would become D into V, and for each of the class I have to do this. So dV into K, right, for these three features and into K, A plus K. So option D would be true, VDK plus K. These many parameters I have to find out to solve any naive Bayes classifier. For a particular instance, it is not required to solve all of that, but for each of the V features, if I have to work on, then I have to need to know these estimate these parameters. Just let me know, guys, if there is any problem in this. If not, let's move to the next question. Yeah, this is next question. This one is really easy. Just tell me what would be the answer here. Tell me, guys, what would be the answer here. Let me give you a sign. And guys, before if you are learning from the session, please like the session so that it can reach to more students and more students can practice these questions. Please like the session, guys. Tell me what would be the answer here, guys. Right. For perfectly spherical 2D data centered at origin, which of the following pair of vectors are possible pair of principal components? Possible pair of principal component. So you can see that principal components are orthogonal to each other. This is the first condition in principal component. So if you will multiply 1 into 0 into 0 into 1, so 0 into 1, 0 plus 0, so you will get 0. So this would be possible. 0 into 0 comma minus 1 into minus 1 comma 0, again 0 plus 0, that would give you 0. But if you will solve this 1 comma 1 into 1 comma 0, it would give me 1 plus 0, that would be 1. So it would not be possible. Only first and second are possible, right? So that's why option D is correct. Right, Rutuja, option D is correct. Right, Kopu, option D is correct. Okay, so here option D is correct. Let's move to the next question. This was simple. Yeah, just tell me what would be the answer, guys, this for this question. Consider a multi-layer perceptron model with one hidden layer and one output layer. Hidden layer has 10 neurons, output layer has 3 neurons. The input to the MLP, multi-layer perceptron, is 5-dimensional vector. Each neuron is connected to every neuron in the previous layer and a bias term is included for each neuron. Then the activation function used is the sigmoid function. Calculate the total number of trainable parameter in this MLP. Principal analysis, yeah, Kupu, principal component analysis is used to reduce the dimensions. So basically, we'll form a covariance matrix, and using a covariance matrix we'll find out their eigenvectors, eigenvalues, and we'll take eigenvectors which are higher eigenvalue, right? We'll sort the eigenvalue in descending order, and we'll take the higher eigenvalues corresponding to their eigenvectors, and we'll see that how much I have to reduce it. So if I'll talk about the mathematics behind uh, behind principal component analysis, so let's suppose I have given f1, f2, fn features, right? These many features I have given, so I'll form a matrix corresponding to that, and using these features I'll find out their variance and covariance, and using the covariance matrix I'll do all the maths behind that. Right, so let's solve this. Consider, so guys, in this question if you will see, we have one hidden layer which has 10 neurons. So that means this hidden layer has 10 neurons, and we have five input layer, five vectors in a five dimensional vector, and one in my and output layer has three neurons, right? And each of the neuron is connected with the previous one. So that means all these five dimensional vector, all the five values connected with this neuron. So that means with this neuron we have this w1, w2, w3, w4, and w5. We have five weights for this particular vector, and we have one bias term, right? So I'll write down here w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus w5 x5 plus b. So that means for this particular neuron I have six trainable parameters in this case. Similarly for this one, because all these five values gets connected with this neuron, and one bias term, so for this one we have six, and for the last one we have six. So in total we have 10 neurons in this, and each of them 10 trainable parameters are required. So 6 into 10. Now I'll come to this one, right? Now these 10 neurons gets connected with this neuron for the output layer, right? So 10 weights and one input, 10 weights and one bias term. So for this one we have 11, for this one we have 11, for this one we have 11. So for in this layer we have 11 into 3, that is 33. So that means 60 plus 33, so total number of trainable parameters would be 93. So in this case 93 would be the correct answer. Total trainable parameters in this multi-layer perceptron would be 93. So let me know guys if there is any confusion that how to find out total number of trainable parameters. If not, then let's find out total number of trainable parameters in this question. Just tell me guys. And you can see that here n number of uh, n dimensional input layer we have, n dimensional vector in input. So guys, you can see that for this layer, for this hidden layer, we have n plus 1 trainable parameters, because n weights, because each of the input layer is connecting, n weights and one bias term. And similarly for this one, n weights and one bias term, n weights and one bias term. So I can in this layer I have 3 into n plus 1 trainable parameters. I'll go back to my next layer, this one. Now for this one you can see that three neurons are connected, previous three neurons are connected, and one bias term. Similarly 3 plus 1, one bias term. So I can write down here 2 into 4, and in this output layer, because of these two weights and one bias term, so that means 3. So how many trainable parameters I have? 3n plus 3 plus 8 plus 3, so it would become 3n 14. That number of trainable parameters are required to model this term, right, Rutuja? 3n plus 14 is the correct answer. Right, so that's how you can easily find out three number of trainable parameters. So let me know, guys, if there is any confusion in finding out trainable parameters. Otherwise we'll move to next question. Okay, so guys, just tell me if you know about hierarchical clustering. So what do we do in hierarchical clustering? We'll draw dendrograms, right? So the question is, given the data set A, B, C, D, E, the following distance matrix construct a dendrogram by complete linkage hierarchical clustering using the agglomerative method. So we have to take complete linkage hierarchical clustering. So in complete linkage hierarchical clustering, we have to take D of AB, and we have to take maximum distance x comma y, maximum distance between x comma y, such that x belongs to A and y belongs to B. So we have to take this to find out hierarchical clustering. So let's use that and try to draw a dendrogram. Tell me, guys, how to draw a dendrogram here. So first of all, you can see that I have given 5 points: A, B, C, D, E, A, B, C, D, E. So first of all, in a dendrogram, I'll take A, B, C, D, E. Right? I'll take these all 5 points alone. Right? So A, B, C, D. Now I'll find out the minimum distance. So you can see that this point C and this point E has the minimum distance. So I'll join them. So that means in the first step, I have all these points A, B, C, D, E. I'll draw this dendrogram. First of all, I'll show you the steps. So in the second part, what would happen? A, B, and C and D gets connected. Right now I have only 4 points: A, B, C, D, and E, because C and D have minimum distance. So we'll join them. Now you will ask that here I'm saying that complete linkage hierarchical clustering has maximum distance, and here I'm taking minimum. Why is that? Because I have to connect which have minimum distance, but this help me to find out the distance. Right, this helps me to find out a distance between two groups. Let's see how. So now my group, I have left with 4 groups. A, B, I have left with 4 group, that is A, B, and then I have C comma D, C comma D, and then I have E. A, B, C comma D, and then I have E. So I just have to find out distance of A with A, that is 0. Distance of A with B, that is 9, already given. Now if I have to find out distance of A with CD, distance of A with CD. So how do I find out distance of A with CD? For that, first I have to find out distance of A with C. What is the distance of A with C? That is 3. Distance of A with D is 6. So instead of taking 3, I'll take this distance 6. So this distance would be 6. Distance of A with E is 11. I hope now you got it. Okay, Kopu is asking that what is hierarchical clustering. Hierarchical clustering basically helps, basically we are doing a clustering using dendrogram. So what is happening here? Let's suppose we have a point A, B, C, D, E. So I'll write down here A, B, C, D, E. I'll take all the points different, right? This is one cluster, this is one cluster, this is one cluster, this is one cluster, this is another cluster. Because you have seen that K means clustering is not helpful when we do not have a spherical shaped data, right? So that's then how, then it does not work. Then I have seen that C and D has the minimum distance, so I'll join them and I'll make one cluster. So in the next step I got one cluster, that is C comma D. Then I have seen that C comma D and B have minimum distance, so I'll join them and I'll get one B C D, another cluster. So now in this stage I have three cluster, A B C D E and E, right? And in the next step I have seen that A and E have minimum distance, so I'll join them. Now at this point I am left with two clusters, A comma E and B C D, and at the last I'll combine both of them to get one cluster. So that means if I have 5 points in my data set, I have started with five clusters and I'll reach to one cluster. And according to my need, according to my question, let's see what are the clusters. So I'll remove this part. I'll remove this part. Right? I'll take A, B, C, D, A and B, C, D and E. Let's suppose somebody asks me to get two clusters. Right? If somebody asks me to get two clusters, then I'll take this AE and BCD. If somebody asks me to take four clusters, so then I'll take this part only. A, B, C, D, and E. So that's how we'll do hierarchical clustering. So our hierarchical clustering is stepwise, and this type of diagram we'll say that that is my dendrogram. Right? So that's what we are doing here. There are two types of hierarchical clustering: complete hierarchical clustering and single hierarchical clustering. In complete hierarchical clustering, when we are taking distance between two groups, we'll take the maximum distance, and in single, we'll take minimum distance. Right? So I hope it is clear. Let's see that now. Let's see this question, then it would get clear to you that how hierarchical clustering works. Okay, now I was finding out the distance. So distance of B with A is 9, distance of B with B is 0. Distance of B with A is 9, B with A is 0. Now I have to find out distance with B and CD. Distance of B with C comma D. For that, what would I do? I'll find out distance of B comma C. Distance of B comma C is 7. Distance of B comma D is 5, and I'll see that maximum distance is 7, so I'll write down here 7. Distance with B comma E is 10. Right? Now distance of C comma D with A, let me erase this. Okay, let's find out distance of C comma D with A. I have already find out this A with CD or CD with A. So I can write down here 6. Distance of CD with B, I have already find out 7. Distance of CD with CD is 0. Distance of CD with E, I have to find out distance of CD with E. That is distance of C with E and distance of D with E. C with E distance is C with E, that is 2. Distance of D with E is 8. So I'll take this distance as 8. Right, now E, distance of E 11, 10. Distance of E with CD is 8 and this would be 0. Right, so this is a distance. Okay, agglomerative method is that if I'll use complete linkage hierarchical clustering. If I'll use this, then we'll say agglomerative clustering is if I'll take the distance maximum. Right? Okay, so we have two types of clustering: agglomerative and divisive. In agglomerative, we just a minute. Okay, in agglomerative, we'll start with 5 single clusters and then we'll, in moving in upward direction, we'll combine them, right? That is agglomerative. And we have second one is divisive. Divisive, what we do? We'll start with single cluster A, B, C, D, E, and we'll see that which have the maximum distance, and then we kept dividing them, right? So if I'll start from the bottom and start joining the clusters, and at the end I'll get one cluster, we call that agglomerative. And divisive is I'll take one cluster at the start and then dividing it further, that would be divisive. We have two types of clustering, agglomerative and divisive. Okay, now next thing we have here is I'll see that which have the minimum distance, not take 0 because you cannot combine A with A. So let's see which one is the minimum distance. You can see that 6 is the minimum distance. 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 6 is the minimum right? So that means I can combine third one. That means I'll get A comma C comma D comma E and B. So that means we get here three clusters in the third step. Just a minute. C E gets combined. Okay, just a minute, guys. There is one error here, because in this case, you can see that instead of CE, we have to combine CE, not CD. Okay, this is one error, because we have to combine C comma E. You can see that this is a minimum distance, and then this is D, right? So it gets an error here. So I have to do it all these things again, right? AB, and then we have CE. C comma E and then D. A B C comma E and then D. Let's find out this distance. A with C. A का distance C के साथ 3, A का distance E के साथ 11. So it would be 11. A का distance D के साथ 6. And then B का distance C के साथ 7, B का distance E के साथ 11. 10. So it would be 10. So we have to take the maximum distance, right? And then B का distance D के साथ, that is 5. Right? Now CE, that would be 11 and 10. C का distance C के साथ 0 and C का distance D के साथ. D के साथ C का distance 9 and D का distance 8. So it would be 8. So it would become 6580. Now you will see the minimum distance. Minimum distance in this we have is 6, right? 6 is the minimum distance. So A gets combined with D. So here I can see that I get three clusters, A comma D, B and CE. Right? This is my third step in which I got three clusters. Right? Now I can get one more clusters. I have to find out this distance. I get two clusters. So what would I take? I'll take A comma B, A comma D, B and C. I got three clusters here. A comma D, B and C. A comma D का distance A comma D के साथ 0. A comma D का distance B के साथ. Tell me guys, what would be the distance of B with A comma D? Distance of A comma D with B. So let's see. Distance of B with A comma D. Distance of B with A is 9 and distance of B with D is 5. I have to take the maximum distance, so it would be 9. Now distance of AD with BCE. How do I find out that? So what I have to find out, let me solve this completely, that so you would know how to find out this distance. Distance of A comma D with C comma E. So what would you do for that? You will find out distance of A comma C. You would find out distance of A comma E. You would find out distance of D comma E and you would find out distance of D comma C. So A comma C is 3, A comma E is 11, D comma E is 8 and D comma C distance is 9. You will see the maximum distance, that is 11. So you would write it here. Right? Now, distance of B with AD. Let's see, distance of B with AD is 9. That is 9. Distance of B with B is 0. Distance of B with CE. That is C, 7 and 10. So it would give me 10. Distance of C with AD, I already find out 11, 10 and this would be 0. Let's see now the minimum distance B. So you can see that fourth cluster would be A comma B comma D, then C comma E. And then the last cluster would be A, B, C, D, E. So you can see that you have started with 5 clusters and you at the end you would reach to 6. What it would be 6? Uh, just tell me, Kupu. Okay, so you have started with 5 clusters and at the end you have reached to single cluster. Okay, so guys, that's how we'll solve it. But you can see that we made one error here. Instead of 6 distance, you have to take this minimum distance as 5. So B and D gets combined instead of A and D, right? So just do this correction, all these calculations you, so just do these all these calculations correctly, otherwise all this would get, all these further steps would get wrong, right? So this cluster, instead of AD, it would become B comma D, right? That is my, I hope you understand the method. That's how you have to work on it. Now let's move forward. So guys, this is another question. In this we have single linkage clusterings. In single linkage clustering, you have to do the minimum distance. Everything else would be the same. You, if you are taking the distance between two groups A comma B, then it would be minimum of x comma y such that distance of x comma y such that x belongs to a, y belongs to b. Now it would not get confused in this one because you have to take the minimum distance. And there is another method, another problem as well, that this is single linkage clustering. There is another method which is average linkage clustering or mean linkage clustering, in which you will take mean of all the distance dxy upon m, and x belongs to a and y belongs to b. You would take this distance and m be the, or you can write down instead of m cardinality of a into cardinality of b. This is also called as average linkage clustering. So just remember in case it comes. Now you would know the concept that in agglomerative clustering, we'll start with 5 clusters, then join them and keep on repeating. At the end we'll get one cluster, right? Okay, so I hope this you can solve it easily. Just take a screenshot and solve it by yourself. Okay, tell me guys, what would be the answer for this? Explain distance. Distance is basically given. Either you can take, if distance is not given, then you can find out using Euclidean distance. What is the Euclidean distance? D of x comma y. If I have to find out this distance, so let's say x is what? X1, x2, and y is what? Y1, y2. If I have to find out the distance, y1 minus x1 square plus y2 minus x2 square. This is Euclidean distance, right? And if I'll talk about Manhattan distance, mod of y1 minus x1 plus mod of y2 minus x2, right? This distance is also there. So there are different types of distance, but in most of the case, Euclidean distance gets used. Right, so let me know guys, in this question, increasing k in k nearest neighbors neighbor model will be. How to determine minimum and maximum values? I told you na, I told you that if they have given the distance, then you can find out what would be the minimum distance in this. You can see that here 2 is the minimum distance out of all those distances. So you have to find out each and every point distance, a with a b c d e, and you have to find out that which 2 points are much closer or which 2 points are very far from each other. You have to work on like that. Right, so let's solve this. Increasing k in k nearest neighbors model will be increased by, if I'll increase the value of k, what would happen? K nearest neighbors, I hope all of you understand it is a supervised learning. What would happen? Let's suppose if I have a, let's suppose I have this data set, right? What would happen here? So let's suppose if I'm taking k is equals to 2, so I want to find out if I have a certain point here. Let's suppose I have a certain point here. I want to know that it is true or false. Let's suppose cross is false and zeros are true. So it would take 4 nearest neighbors, and it will find out how many trues are there, how many false are there. So maximum number, if maximum number are true, then it would give this point true value. If it is maximum numbers are false, then it would give me false value. So here I can say that it would assign this as false value because 3 cross and 1 zeros are coming, right? So this is k nearest neighbor. So they are saying that if I'll increase the value of k, then what would happen? Increasing k in k nearest neighbor models will. Acha, can you tell me, let's suppose if in a model, if I have n values, then what would be the maximum value of k can have? What would be the maximum value k can have if I have n input parameters, if or else say n trainable parameters? Here I have n trainable parameters, then what would be the maximum value of k can have? So maximum value of k can have here is n, right? Let's suppose maximum value of k can have here is n, right? What can be the maximum value? Would be n. So that means for the whole data set, let's suppose what would it would do, let's suppose I have 200 values in the data set and I'll take k is equals to 200. Then if I'll take any another point here, then what would it would do? It would count how many trues are there. Let's suppose I have 101 trues and 99 false, right? So that means for every new point it would assign true value, because I can see already I have, if I have 101 values that are true, right? So that means it would work on that what are the maximum number of values we have here, right? If we have maximum number of values true in the neighborhood, then it would assign true to for each of the value. For each of the new instance I'll take, it would assign true value to it. So that means this is a case of underfitting. It would be the case of underfitting. If this is a case of underfitting, then what would be the effect on bias and variance? Then it would increase both bias and variance, because bias would get sorry, what would happen with bias and variance? This is a case of underfitting. In underfitting, what happens? High bias, high variance, right? So you can see that in this case our bias gets increased, right? Testing error gets increased here, training error gets increased here, because this is a case of underfitting, because all the 95 points it's giving me wrong value, right? 95s are false, 99 are false, but if I'll check using my modeling, it would give me true value for each of the one. So that means we have a lot of training error. Lot of training error, that means I have high bias if I'll increase the value of k. And for each of the new point as well, it would give me high variance, because for each of the new point it would assign t, either it can be false or true, right? So in this case we have high variance and high bias. Okay, so let me explain it again, guys. So let's suppose if I have n is equals to 200 points in my data set, right? N is equals to 200 points, out of which I have 101 true and 99 false. Now they are saying that what would happen if I'll increase the value of k? What would happen if I'll increase the value of k? So at max, what value of k I can take? I can take k is equals to 200. Let's suppose in this data set I have given so many values. In this I have so many values. That means I have 200 values. That means in this case we have 101 true and 99 false, right? And I know that we do not have to train, we just have to take new instance. Let's suppose I'll take any new instance here. I'll take any new instance here. I want to know that what would be the classification for this point. So I'll take the uh, whole data set as my neighborhood, because I have taken the value of k is equals to 200, right? I have increased the value of k. But for this point, you can see that because 101 are true and 95 are false, it would assign true value to this point. It would assign true value to this point, right? If it would assign true value to this point, so that means I am getting, for every value I am getting true answer. So you can see that for each of this false points as well, it, because I have 99 false values, but if I'll check again using my modeling, k is equals to 200, I can see that 101s are true. So it would assign for all these 99 value, it would assign true value for that. So that means in this case my bias gets increased. My bias is increased. That means my training error increased, because for all the 99 values I am getting the wrong answer. 99s are already false, but I am getting a false. Kapu, just tell me why there would be a decrease in variance. So variance, I told you at the start. I told you variance at the start, that if it would work different on different data sets, then that would be an variance, right? But for different data set, it is giving me true answer, right? It is giving me true for every value. If I take any new instance as well, it would provide me true value, right? So if I'll talk about testing error, then there is also an error in testing, right? So it would increase bias and increase variance, because we, our testing error and training error both gets increased, right? So I hope it gets clear. Okay, let's move forward. Just let me know, guys, if there is any confusion. Otherwise, let's solve this. This is a question based on naive based classifier, and our test instances slow, rarely, no. So I just have to classify this. If an animal swims slow, sorry, if a species swims slow, fly rarely, and no crawl, then what would be the class for that instance, for that species? I have to classify that. So that means using naive based classifier, I have to work on it, right? So I told you first you have to find out all the probabilities. So you have to find out probability of animal. Let's take animal as c1, fish as c2, and bird as c3. So if I'll find out probability of c1, that would be, because I have 5 animals out of 12, so probability of c1 would be 5 by 12. Probability of c2 would be 3 by 12, and probability of c3 would be, probability of c3, that means fish, sorry, bird, 4 by 12. I got these probabilities, right? Copo, underfitting means high bias, low variance, but in this case we are getting variance as well. We are getting high bias as well as high variance. Okay, let me write it little bit below. So here I am getting probability of c1 5 by 12, probability of c2 3 by 12, probability of c3 4 by 12, right? I got these probabilities. Now I have to check for this test instance. So I, that means I want to find out probability c1 given x, probability c2 given x, probability c3 given x, and I know that already, that probability c1 given x is approximately x given c1 into probability of c1. So can I write down this as probability x1 given c1? probability x1 x2 given c1, probability x3 given c1, and into probability of c1. So what is c1? X1. This slow is x1, this really is x2, and this no is x3. Let's see the c3 classes. These three are c3, this is c1, and these two are c1, right? So let's check in that. So out of the swim option, I want probability of x1. So I can see that slow is here and slow is here. So out of 5, we have 2 slows. So that means probability would become 2 by 5. X2 given c1, that means x2 is rarely. So let's check that in this rarely. We have only one rarely out of these 5 options. So that means 1 by 5. X3 given c1, x3 is what? No. So I have 1 no, I have 2 no, I have 3 no's. So that means 3 by 5. And I'll write down the probability, that is 5 by 12. If I'll solve this, I'll get 2 6 are 12, 3 2s are 6. On solving, 10.02. We get this probability, right? That is 0.02. So I got the probability c1 given x. Now I want to find out the probability c2 given x. Again, same thing. Probability c2 given x would be probability x given c2 into probability of c2. That means probability x1 given c2, because these, in Bayes theorem, these features are independent of each other. Probability x2 given c2, probability x3 given c2 into probability of c2. So let's check now for c2. Let's check for this c2. C2 is what? C2 is fish. So this one and these two cases. So now I have to check for slow. Out of these 3 values, only 2 are slow. So 2 out of 3 is the probability x1 given c1, x1 given c2. Rarely. Let's check for rarely. So there is no rarely. So 0 by 3 is the probability. Now check for no. I have 2 no's. 2 by 3 into probability of c2 is 3 by 12. So we would get this value 0. So this probability gets 0. Now guys, tell me what would be the probability of c3 given x. Let's check for probability c3 given x. Let me know in the chat section, guys. This is a question. Tell me guys, what would be the probability? So what would you get? Probability x given c3 into probability of c3. And guys, just solve by yourself. In this case, you also get the probability 0. Right? If you would get the probability 0, then that means which probability is maximum? Given this instance, probability of c1 is maximum, right? Given this instance, probability of c1 is maximum. So that means this has the classification c1, right? So that means this species would be an animal. I hope you guys get it, how naive classifier work. Kupu, you are asking that how naive classifier works. That's how naive classifier works. Okay, so yeah, let's solve next question if this is clear. Yeah, this is a question based on artificial intelligence. So we have given this game tree and they are asking that which nodes we can prune using alpha beta pruning. The value below each node is the output of the utility function. The subtrees rooted at which of these nodes would be pruned because of alpha beta pruning. So tell me guys, which rows can be pruned? This is one of the question based on gate mock. So guys, see what would happen. Maximize has to maximize its utility and minimize has to minimize max utility, right? I hope all of you know about that. So what would happen here? This minimum, this maximum would try to maximize its utility. So you can see that here k can be this alpha. let's take alpha. Here alpha can be greater than equal to 3 for the, because of this, and this is 0, so that means this does not make any impact. Now for minimize, here you can see that this is beta would be less than equal to 3, but here this is 2, so beta would be 2 here. Beta would be less than equal to 2, or I can say here beta is equals to 2 because it gets required here. Beta is equals to 2. Now I'll go here, right? So now you can see that uh, because here you can see, if I'll see here minimize, right? This m has to minimize, right? So you can see that here beta would be less than equal to 1 because this would, he would play this role, this chain, this thing. But you can see that maximize has to maximize its utility, right? So here at max value can be 1, here at max value can be 6, so that means alpha should be greater than equal to 6 because he would play this chance, not this one. So that means here this r gets pruned because we do not require that for this utility, right? Similarly, now for this one, here you can see that this is minimum, and here I have gone, I have seen that beta is less than equal to 1. So you can see that here, because this one has to maximize its utility here, because for this minimum value alpha can be greater than equal to 6, and this is 6, so here beta is equals to 6. Because of this to maximize its utility, what would it do? It would be max, so alpha should be greater than equal to 6, right? So now you can see that, now you can see that here you are getting 6 and you do not require this utility, right? So using this node r and j, so which of the nodes you can prune? You can prune r and j. So these are the option. Now you can prune the nodes r and j, right? So I hope this is clear to you. R and j would be the right answer for this one. Just let me know guys if there is any question in alpha beta pruning. Just let me know guys. Okay, so guys, that's all for this session. All the best for your exam. There would be no session tomorrow. And guys, I hope we all helped you. And if you want to look more session based on machine learning or based on any another gate data science topic, you can check the first comment pinned here in GFG, which will lead to your our main our channel, which is Geeks for Geeks Gate Computer Science. And there you would get all the information if you have to practice more because of this timing, and we have all these to you. So just, I hope all of you get it. If there is any question, please ask, otherwise I'll end this session. And thank you guys for joining. And guys, at the end I just want to say that you are fully prepared, and just take a good sleep before the exam, because I do not want that you guys feel uncomfortable in the exam. So last moment study would not work in any competitive exam. So just take a rest of one night before the exam, and just be confident and you would be able to crack it. Okay, yeah, so that's all from my side. Okay, thank you guys, thank you for joining.